All right, in this problem that I'm going to attempt for the 14th time, okay, not quite that many, but it feels like it. Because I always get to one point, it's like, oh, I made a sign error. Oh, I did something. Yeah, it happens. Anyway, a light source is located over the center of a circular table of diameter 4 feet. Find the height h above the light source, of the light source, such that the illumination I at the perimeter of the table is a maximum if I is equal to k times the sine of alpha divided by s squared, where s is the slant height. Alpha is the angle at which light strikes the table, and k is a constant. Okay, well, first things first, let's draw this out. And so if we just create a little light bulb here, I'm going to kind of create a little rectangular light bulb because, well, that's what the new ones look like. So we have coils in here. So our better fluorescent light bulb. And then we're going to create a table. Now, table's circular. However, when you look at it from an angle, it tends to take on a much more elliptical shape. And so I'm going to draw it as such. And light is kind of yellow, and so it's going to come down here and hit the corners or hit the edges of that circular table. And when it does, it's going to do it at a slant height of s. Now keep in mind, this is a cone. This is a three-dimensional object that we're looking at here. So the slant height s, if we're looking at it kind of from the side, is actually going to turn out to be the hypotenuse of a triangle. The diameter of the table will form the base of the triangle. It will be 4 feet, or split up into 2-foot lengths on the radii. The angle that the light makes with the table is the same on both, and this is going to be alpha. Okay, now we need one more piece, the height. So as we come down and hit the center of the table, this value here is the height. So we've got I is equal to k times the sine of alpha all over s squared, which means we can do one of two things. We can either try to put all of this stuff in, try to convert all of this over to where h is the variable, or we can relate other thing or h back into other things. And now what I'm going to suggest here is that you actually go about this from a trig perspective. And the reason being is because trig can be manipulated quite easily in relative of other things. Since you are dealing with triangles, if you choose to go the length route, you'll have square roots. Not to say that you can't get the answer. It's just to say that you're going to be dealing with lots and lots of square roots. And taking derivatives of those usually involve the chain rule as well as the power rule. It gets kind of messy. And so I'm going to work through this using trig. So everything I want to do is going to happen through sines and cosines. And so I need to find a way to relate s back to alpha. And I can do that if I use cosine to define it, because the cosine of alpha is equal to the adjacent side, which is 2, divided by the hypotenuse, which is s. And so if I solve for s, that means that s is going to be 2 over cosine alpha, or s squared is equal to 4 over cosine squared alpha. Now, you can go ahead and switch this to secant if you want, but I don't like secants and tangents and all that stuff when I got to take derivatives. So I am not going to choose to do it. Instead, I like fractions, and so I'm going to simply put that in for s squared. I have the sine of alpha on top. Underneath, I've got 4 over cosine squared alpha. All right, so now if I kind of work that around here, I get k over 4 times sine alpha cosine squared alpha. And the reason I bring the k over 4 out is because when I go to take the derivative, the next step, I can treat that as a constant and just hold that out on the side. Okay, so now I've got k over 4, the constant comes out. And now I need to take the derivative of the first thing. Derivative of sine is cosine alpha times the second thing, which is cosine squared alpha, plus the derivative of the second. Now here we need to be very cautious because this is going to be 2 times cosine, the derivative of the outside, times the derivative of the inside. The derivative of cosine is negative sine alpha times the first, which is sine of alpha. So let's go ahead and close that off. Now let's take a look at this here. We want to set this equal to 0, so 0 is equal to k over 4 times, and now let's clean this up a little bit. So we've got cosine cubed alpha plus 2 cosine alpha negative sine up. Let me erase that. Let me set this up a little differently here. We're going to have this be a negative instead of having to try to keep that negative around. So negative 2 cosine alpha sine squared alpha. Okay. So now because 0 is equal to that, it means that the first thing is 0 or the second thing is 0, and the first thing being 0, that would just kind of trash the whole mess. Our illumination strength would go to 0, and therefore this would be a moot point because k would be 0. So since k is not 0, we can go ahead and divide through by that. And now we have 0 being equal to cosine cubed alpha minus 2 cosine alpha sine squared alpha. Now, cosine, okay, we can't divide by 0. So cosine is 0 if the angle is 90 degrees, but the angle can't be 90 degrees according to our picture. If it was, then we'd be looking at 2 separate light sources hanging over the very edge of the table, and that just doesn't happen. All right, and so it cannot be 90 degrees. Since it can't be 90 degrees, we can go ahead and divide through by cosine. And so I'm going to divide through by a cosine on both sides. And when I do that, I get 0 is equal to, that drops this down to 2, and it just cancels that one right on out. So I get cosine squared alpha minus 2 sine squared alpha. Well, now if this were plus, we could probably use some sort of trig identity, but it's not. And it's not cosine squared minus sine squared, which would be, I believe, sine 2 theta. And so we can't quite use that. But if we take Pythagorean's theorem, which says that it's cosine squared theta plus sine squared theta is equal to 1, then we can solve for cosine squared theta by subtracting sine squared theta from both sides. You get 1 minus sine squared theta. All right, well in this case, alpha is our angle, and so if we rewrite cosine, then it becomes 1 minus sine squared alpha minus 2 sine squared alpha would give us 1 minus 3 sine squared alpha. When that happens, then we can just move that over, so it's 3 sine squared alpha equals 1, meaning that sine squared alpha is equal to 1/3. Taking the root, we notice that sine of alpha is equal to 1 over the square root of 3. Okay, so that's the sine squared alpha part. Now, we've got that. But if that's true, then let's start taking a look at writing h then. Because that's what we really want is h. And so, if that's the case, then we need to find a good spot where this is true. And so where is sine equal to 1 over root 3? So now that we've got sine, let's go ahead and take that and take it back to our picture and see if we can't find a good way to use that. So sine in this case would be the opposite over the hypotenuse. And so if we look at that way, then we have, and I probably should grab that here. Let me see if I can cut that stuff over here. Oops. Cut, paste, and just kind of move this stuff over this way. And this is just to kind of give us a little bit more room here to see. But now sine of alpha is equal to the opposite, which is h from our drawing. Okay, so here's our alpha. H is the opposite. S is the adjacent, or I'm sorry, the hypotenuse. And so since we have that, if we want h, then this is s times sine of alpha. Alpha is equal to h. S is 2 over cosine alpha. So this is 2 over cosine alpha times sine alpha. So now that we've gotten to this point here, I'm going to need, this is 1 over root 3 equals h. I need cosine. All right, so now I know that 1 minus sine squared alpha is equal to cosine squared alpha. And so if I take the square of this, that's going to be 1 over 3, and so that's going to give me 1 minus 1/3 is equal to 2/3, which is cosine squared alpha. And so now I've got square root of 2/3 is equal to cosine. And so now if I go ahead and put this in for cosine, this gives me 2 over root 2/3 times 1 over root 3. Root 3 here equals h. So now this is going to be 2 over root 2. The root 3 comes up. Okay, you can split these into root 2 over root 3. The root 3 will come up to the top. And since I'm multiplying by root 3, I've really got, this cancels with that. And so I've got 2 divided by root 2, which is just root 2. And so that's the height. It was a fairly long problem, and this didn't look all that complicated when we first started out, but as you can see, it got a little complicated. And the idea here is just peck away at it. Since you're dealing with your trig functions, you can always go back and look at your identities. They can usually yield some sort of hint for you. If you attempted this through the other version, I'm not going to do it. I've attempted it 3 times. I can't get the numbers to work. I always make a sign error usually. And so it's been taking me a couple hours of good hard work, and I've got other videos that I need to make. But I will certainly try to get another video up to where this is solved the alternate way, meaning that when we get down to it, when we start taking the derivative, we're actually taking the derivative with respect to h. That might be kind of interesting if I can get it to work. So just keep plugging away at it. And don't forget, sines and cosines always average out in the end.